The topic we are going to discuss about is atomic structure, and the subtopics are quantum numbers and principal quantum numbers. Before going into the details of quantum numbers, let's see why we need quantum numbers, and the answer of why lies in the drawbacks of Bohr's atomic model. Objections were being made on Bohr's atomic model about motion of electrons in 3D space, spectra of polyelectron atoms. Bohr's model failed to justify these two objections. Then Schrodinger came forward with his mathematical equation in order to explain the 3D motion of electrons. Schrodinger in 1926 gave the idea of motion of electron. He formulated an equation in which electrons are treated as moving with wave-like motion in 3D space around the nucleus. So Schrodinger wave equation is defined as a mathematical expression describing the energy and position of the electron in space and time, taking into account the matter wave nature of the electron inside the atom. And the equation is h nu equals to E nu. Let's see on which theories Schrodinger basically formulated the mathematical equation. It is based on three considerations: classical plane wave equation, Broglie's hypothesis of wave matter, conservation of energy. Let's define quantum numbers. It is defined as the set of numerical values which give the acceptable solutions to Schrodinger wave equation for hydrogen atom. Quantum numbers are basically there is a set of numerical values, ये mathematical values हैं that give acceptable solution to Schrodinger wave equation for hydrogen atom. So basically quantum numbers tells us about the whole address of an electron. An electron in an atom is completely described by its four quantum numbers. Quantum numbers serve as label or identification numbers which completely describe an electron. These quantum numbers specify position of electron in an atom. The most important thing, quantum numbers tells us about the position of electron in an atom, in which orbit, in which orbital, or in which axis the electron is revolving around the nucleus. Next are the classes of quantum numbers. There are four quantum numbers which describe the electron completely, and these are principal quantum number denoted by n, azimuthal quantum number denoted by L, magnetic quantum number denoted by M, and spin quantum number denoted by S. If we take an overview of quantum numbers, then principal quantum numbers tells us about the distance of electron from nucleus. Azimuthal quantum numbers tells us about the shape of the orbital. Magnetic quantum numbers tells us about the orientation of the orbital, while spin quantum number tells us about the orientation of electron spin, either clockwise or anticlockwise. Let's discuss principal quantum number. The different energy levels in Bohr's atom are represented by n. N is principal quantum number. This is called principal quantum number by Schrodinger. Here is a model of atom. न्यूक्लियस के गेट ऑर्बिट्स हैं या आप इन्हें शेल्स भी कह सकते हैं, और इन्हें हम रिप्रेजेंट करते हैं n यानी कि प्रिंसिपल क्वांटम नंबर से, और इन शेल्स को श्रोडिंगर ने प्रिंसिपल क्वांटम नंबर का नाम दिया जबकि बोहर ने इन्हें ऑर्बिट्स कहा था. Let's see the characteristics of principal quantum number. Its values are non-zero positive integers up to infinity. N equals to 1, 2, 3, 4 up to so on जितने भी हैं. Remember one thing, यहाँ पे 0 नहीं आएगा. प्रिंसिपल क्वांटम नंबर की वैल्यू 1 से स्टार्ट होगी. The value of n represents the shell or energy level in which the electron revolves around the nucleus. Later notations like K, L, M, N are used to denote various shells. Here you can see these are the orbits or shells जिन्हें हम principal quantum number से denote करते हैं. 1, 2, 3, 4. 0 से start नहीं होगा shell would be first shell then second. और इन्हें हम जो letter notations हैं उनसे denote करते हैं. First shell is K, second is L, third is M, and fourth is N. Let's discuss the physical significance of principal quantum number. Value of n determines the location of electron in an atom, the distance of electron from the nucleus. Value of n tells us about where the electron is revolving around the nucleus. If it is in first orbit, n की value 1 है, मतलब वो nucleus से nearer है. But अगर वही orbit की value 4 है, मतलब वो relatively further move कर रहा है nucleus से. Greater the value of n, greater will be the distance of electron from the nucleus. It is quantitative measure of the size of electronic shell. First shell है n equals to 1. Shell का size जो है वो कम होगा as compared to shell number 2. उसका size जो है उसकी periphery थोड़ा बड़ा होगा. N provides us energy of electron in a shell. So in this diagram you can see if a shell is nearer to the nucleus, उसका size उतना ही छोटा होगा. जैसे जैसे हम nucleus से दूर move करेंगे उसका जो size है वो बड़ा होता जाएगा. अगर एक इलेक्ट्रॉन फर्स्ट शेल में प्रेजेंट है तो वो न्यूक्लियस से करीब होगा एज कंपेयर टू दैट इलेक्ट्रॉन जो थर्ड या फोर्थ शेल में प्रेजेंट है वो न्यूक्लियस से रिलेटिवली दूर होगा एज कंपेयर टू दैट इलेक्ट्रॉन दैट इज प्रेजेंट इन द फर्स्ट शेल. Let's see how principal quantum number tells about the distance and energy of electron revolving in an orbit. Bohr's results helps us to know the relationship of distance and energy of electron. Rn equals to 4 pi epsilon naught n square h square over mze square. So greater the value of principal quantum number, greater would be the distance. E equals to minus z square me4 over 8 n square h square e naught square. So n and e are inversely proportional to each other. So if we want to calculate the total number of electrons in an orbit, we have a formula of 2n square. If the value of principal quantum number is 1, shell would be k and total number of electrons would be 2. In shell number 2, number of electrons would be 8. In 3, it would be 18. And in fourth shell, that is n, total number of electrons would be 32. Let's discuss a practice MCQ. The maximum number of electrons that can fit in all orbitals with n equals to 2 and L equals to 1 are 2, 10, 6 and 14, and the correct option is 6. So this was all about principal quantum number. I hope you have understood it well and thank you so much.